Hi everybody, it's Miss Lorenz and this is the third lesson. Actually, it's the very last lesson for the unit. So this is for compacted math for the week of May 11th through the 15th. You might choose to have out your math notebook, pause this video as you go so that you can combine like terms in all four of these examples that I'm going to give today. So let's get to it. So all week we've been talking about combining like terms. And remember, this is just a really useful strategy. You're going to see this again and again in your future work. It's also a great application to the properties of operations. And that's one of the reasons I really like focusing on our properties of operations as we combine like terms. So here's my example for the distributive property. If we have a problem like this, 2x plus 9x, we can factor out an x, right? Because that's a factor that's in common here and here. And then we're left with x times 2 plus 9, and we know that 2 plus 9 is 11. So this allows us to combine like terms by using what we know about the distributive property. Now, I get it. You guys probably looked at 2x plus 9x and already thought of it as 11x. This is just serving as an example of how you're using that property. We also use the commutative and the associative properties when we combine like terms. So in this example, we have 2a plus 3b plus 4a plus 5b. The first thing we're going to do is we're going to commute. So we're going to trade places with 3b and 4a. And remember, addition is commutative, so we can do that, and it doesn't change the meaning of the expression. By doing that, we end up with 2a plus 4a plus 3b plus 5b. Now what we're going to do is we're going to associate the 2a and the 4a together, and we're going to associate the 3b and the 5b together so that we can end up with 6a plus 8b. Now, like before, I know that you could look at this and you might have just already in your head combined the 2a and the 4a and the 3b and the 5b and kind of hopped around and came up with this without having to go through all those steps. Yeah, of course you did. That's not the point. The point is that we're using the commutative and the associative properties as a way of combining like terms. This is something you're probably still working on, maybe struggling a little bit with. It's this idea that we can change subtraction to addition so that we can apply these properties. Remember, only addition and multiplication are commutative. Subtraction is not commutative. And what I mean is if we have a problem like 2 minus 1, subtraction is not commutative. We can't just say that that's equal to 1 minus 2. That's not correct. Subtraction is not commutative. But if we change subtraction to adding a negative, then we can commute it, right? So then we can, this meaning now has the same meaning as this. So that's what we're going to do here. We're going to change subtraction to addition so that we can apply those properties. So if we have something like 2a minus 3b minus 4a minus 5b, we're going to change all those subtractions to adding a negative. So we end up with 2a plus negative 3b plus negative 4a plus negative 5b. Then we're going to commute the 3b, negative 3b and the negative 4a so that we're left with 2a plus negative 4a plus negative 3b plus negative 5b. And then we're going to associate. So we're associating the 2a plus the negative 4a and the negative 3b plus the negative 5b. Then when we solve what we have in our parentheses, we're left with negative 2a plus negative 8b. And we can write that then as negative 2a minus 8b. All right, one more example. In this example, this is kind of like a factoring challenge here. So if you want to, you could pause right here and write this down. The factoring challenge idea is that I just want you to remember that terms can be combined in any sum where there's a common factor in all the terms. And so if you look at this expression, x plus 3 is the common factor. It's here, and it's here. So we're going to factor out that common factor. So we have an x plus 3, and then we're going to multiply our x plus 3 times everything we have left, which is our 5 minus our 5/10 plus our 2. So then when we solve what's in parentheses here, 5 minus 5/10 plus 2, we end up with 6.5. So then we can write this expression because we know that multiplication is commutative, so we can switch that around. We can write that as 6.5 or 6 5/10 times this factor x plus 3. So hopefully that makes good sense to you and you are ready for the unit test. Hopefully tomorrow. Thanks, guys.